Okay, this is going to be our first example of when substitution is necessary. We're trying to do the guess and checking chain rule backwards way, and when that completely fails, we do substitution. But don't do substitution unless it's absolutely necessary, and we're going to look at an example that's absolutely necessary. You can see that there's this big long procedure here. I am going to follow the procedure. I suggest that you actually have this in hand while we're going through the problem. So let's go look at the problem. Problem looks like the antiderivative of x times x plus 1 to the 100th dx. Now, I am going to try to just follow the procedures that we're laying out. First off, let's just make sure that the other things don't work first. That doesn't match anything on our derivative test. If I try to guess and check, by the way, x plus 1 would be our blob, but the derivative of x plus 1 is 1, and there's this extra x left over. That's just really troublesome. I could rewrite this. I could actually multiply this out 100 times. Multiply all of those terms by x, and then just use the power rule, I think 101 times. But let's not do that. Let's just try something else. So I want to do substitution. I'm going to try to follow the procedure as we laid it out. Now the way I do this, we have three regions that really can't touch each other. Right over here, I'm going to call this the x region. Let's see here. Can I see the x? How far right can I go? Okay, there's x. That's going to be x land, right? Then there's going to be this works stuff in the middle where w's and x's can exist together but not in the same integral. And then over here I want to have w land where I can't have any x's at all. Now, the procedure says find an inside function. Well, since we already actually tried to do this by guess and check, we know that the inside function should be x plus 1. Now, for what it's worth, in almost all of these problems where substitution is necessary, solving for x is also going to be necessary. So I'm going to solve for x. I'm going to write down that x equals w minus 1 like that. Now the next thing they say to do is draw an integral far, far away, over in w land. Now wherever I saw an x plus 1, put a w, and I see the x plus 1 inside the 100th. So I see w to the 100th over here. Now the next thing they tell us to do is to circle everything that's left, right? So I haven't taken care of the x yet. I haven't taken care of the dx yet. And what do I mean by take care? That integral turned to integral. The x plus 1 to the 100th turned into w to the 100th. I don't know what x is. I don't know what dx is. The next thing, according to the procedure, because we need dx, is we have to take the derivative of both sides of something with respect to x. And what I'm going to do is take the derivative of this one, of both sides with respect to x. When I take the derivative of the left-hand side with respect to x, I get 1. When I take the derivative of the right-hand side with respect to x, I get dw dx. Now the next thing it says in the directions is eliminate the denominators of dx's. So I'm just going to multiply both sides by dx, and I'm going to get dx equals dw, like that. Now what does that tell us? That says wherever I see a dx up there, I can put a dw over here. I'm going to do it like that. Now, the only thing that's left to take care of is x. That was, by the way, the one thing I couldn't get rid of when we did guess and check. But since we solved for x here, we see that x is just w minus 1. So right here, I'm going to put w minus 1 like that. That's certainly a different looking integral. Why is this one easier? It still doesn't match my table. It really can't do guess and check, but now I can rewrite with ease. Right? This is going to be w to the 101st minus w to the 100th. This is all dw, like that. Now, I can take the antiderivative just using the power rule twice. Right? This is going to be w to the 102nd over 102 plus w to the 101st over 101 plus c, like that. And we actually were able to take an antiderivative. Now, we're not quite done because my original integral had x's in it, and my answer has w in it. So what I need to do is walk my w's back through translation land and substitute back. So what do I get? I get, let's see, instead of w to the 102, I get x plus 1 to the 102, like that, all over 102, and then I get plus x plus 1 to the 101st all over 101 plus c, and we get a final answer, which is great. Now, by the way, you can now see why guess and check didn't work, right? How in the world was I supposed to guess at something like that? But meanwhile, that's the whole problem. We start with something that where nothing else works. We decide on substitution. We usually solve for x. We substitute until every little piece of the original integral is actually taken care of. And then hopefully we get an integral we can do. And once we do the integral, we go back. That's the end of our first example.